Okay, good afternoon. Hi. Hi, everyone. My name is Lenz. I'm a Flutter developer. I work for a company called CMIC, based out of Toronto. Been working with Flutter for about 5 years. Today, I will present to you generics and Dart. For my socials, please feel free to follow. So today, we'll explore generics, powerful feature in Dart, and many other languages. Generics help make your code more reusable, more readable, and make sure that your code can work with a variety of data types. We will, we'll discuss the basics of generics, what they are, the syntax, how to use them in your code. Then we'll see how you can leverage them to improve your productivity, improve the quality of your code, and even the performance of your applications. Finally, we'll look at a demo where I implemented the repository pattern using generics and Dart. First of all, I'm curious, who here is a complete beginner in Flutter or Dart? Okay. Awesome. Okay. So please feel free to ask questions. Okay, generics, what they are. Generics, they're a way to define classes, interfaces, functions, methods with placeholders for types. They operate for the types that they operate on. They allow you to write type-safe code without specifying explicitly what the types are. They are defined with angle brackets. Here we can see the T. T is the type. So we have an example here where you have a box of type T, and T could be a string, an integer, double, or any other. It could be a database record, could be any type that you want it to be. A common example of generics are collection literals, lists for specifically lists. If you look at the definition in the API documentation, you'll see you have list of type E, where E by convention stands for element. So you can have a list of, again, any type that you want it to hold. There are many other there are other collection literals that you can use. So we looked at lists just before. You can use generics on sets and maps. So the way that you do that is that you specify the type in brackets before in angle brackets before the opening bracket of your collection literal. You can also use generics on classes. So you do that by specifying the type after the name of the class. You can also specify generics on functions. So you do that by specifying the type after the name of the function. Generics on function give you generics on functions and methods. They give you access to the type in many places. So you'll have access to the type in the argument. You'll have access to the type locally in the function, and you'll have access to the type also as a return value. I'm just disconnected something here. I hope it wasn't nothing important. All right. Yeah, please go ahead. No, it's not a list of T, it'll be T. List is the class, so you'll return, let's say you have a list of strings, this will be a string.
So why is it the first brackets T? It's like this.
Y is this one. So this is your type. Whatever type you want to pass, whatever type you want to use for your function, you can pass it here. So here we say list, right? We say list of t. It could be just t. So let's say this is string. You could say t. So this would be a string. This argument would be a string. This would be a string, right? So t is just your type. It's a placeholder for your type, whatever the type is. Right? So this is just you're defining as you're calling the function. This is where you say this is the type that I will use in my placeholders. Same for classes and collection literals. Does that answer your question? So you can also restrict the parameterized type. And this can be useful to ensure that you have common functionality. This is done by using the extends keyword on the type t. Okay. So here we have our infamous box from the beginning, and we can see that we specified that the type that the box contains will extend num, which is either one of integer or double. So we said we call it number box. So here, when we instantiate our class, it could be a number box of integers, which is okay to take a number, an integer. It can be in the number box of double, which is okay to take a double, but it can't be a number box of string, because string does not extend num. And the advantage of generics is that they'll give you a compile time error. It's not going to be a runtime error. As your app runs, it won't throw the error. You'll see it in your linter, and basically you won't be able to compile. By convention, generally, the types are a single letter. E for elements, KV for key value pairs, R for the return type. So these are the letters that we use by convention. And for the single letter types, we use a single letter. So like T, S, U are the common ones. That's the convention, but descriptive names can also be good. Adrian. Adam.
Can you, for example, use, let's say, the R type here and use it to cast your return type to, let's say, you input something, sometimes you want to integer back, sometimes you want to float back, and you kind of cast in your return to that type.
I believe that will work on doubles, yes, on integers and doubles, because they're implicitly casted. You guys can hear me, right? Yeah, they're implicitly casted, but I don't think you can do much more than that. Does that answer your question? Does anybody validate what I just said, by any chance? I have to test it.
Can you repeat your question now, please?
So
it's just like, can you kind of use the R arguments of your generic type to kind of cast your return to that type?
So let's say you return an integer and your R is a double. Is it going to be a compile time error?
Runtime. Because when
It'll be runtime.
When you cast, it's runtime. It's never double.
No, it's a compile.
If you know, if you're
It doesn't let you compile.
It doesn't compile.
It should be integer.
But integers will be casted to double automatically, I think. Not even like implicitly.
So Flutter allows you to cast, but it will cause a runtime. I believe.
Okay, something to test, basically, to confirm. Good question. Huh? Yeah, we'll try it on Dartpad. Remind me, we'll try it after. Yeah, it's a good question. Awesome. So so I was saying single letters by convention. Descriptive names are also good though. Sometimes you don't quite fit in the convention. So descriptive names can be good, specifically when using many generics. Consider using descriptive name to convey information about the type, what the type represents. So here, for example, we say item 1, 2, 3, and then result type. Because we're merging collections, we're merging these 3 items. So this is, I don't know, let's say a database record, workout items, nutrition item, or whatever, journal entry. So it's clear when you see it like this. And the top example, when you see TUVR, it's not always super explicit. So that's why this slide. Awesome. So some benefits of using generics in your code. First, they improve code reusability. That's definitely a big one. They allow you to write a single piece of code that can work with many different data types, eliminating the need to have to rewrite logic across your code. Second, generics can enhance the type safety. Like we were just talking about, the compiler will complain if you don't use the right type as per the generic. And this can lead to, of course, it can lead to more robust and reliable code. And finally, generics will actually improve the performance of your application because the Dart compiler can generate more efficient code if it knows the type. If we look at type safety examples, well, I think we kind of looked at that, but you can see here we're using collection literal of string. We can add strings if we try to add a number. Compile time error, we can't do it. We talk about reusability. Reusability is a very important part of using generics. It allows you to create flexible components, decentralize the logic to reduce duplication of your code. And we'll see in the demo where I use it, and I use generics for centralizing the logic, writing and reading from a database. High level, that's what I wanted to talk about concerning generics. I'll take questions here, and then we'll go to a demo. All right, questions so far?
I had a difficulty to.
Fuzzy. Hello.
I had a difficulty to implement something like. First of all, I was initializing the constructor, but I didn't know the type. But I want to have a type properties inside of my class. For example, I have a class A, and I have a properties with the type of T, a generic type of T, results. But I don't know the type of T when I'm instructing the class. Is there any option that I can do and I want to use the result in the future, in the life cycle of the application, but I want this T to be types. I don't know if you understand me, but
I'm not 100% sure. You're saying you don't know the type of T, that's fine. But so
when I'm initializing the class.
When you're initializing the class, you don't know the type of T?
In the future, I know the type of T.
Ah.
And because of business logic, you determine all of it as a type
Yes,
something.
yes.
You want to determine the type.
In the future, I want to be type, not dynamic.
So you want to create your instance of.
Dynamic, but I don't want to use dynamic for objects.
So you want to create an instance of your class that uses a generic without passing the type,
Yes.
and then later you want to enforce that type.
So you should know in advance and maybe extend something or do something.
Yeah, I don't think that's a possibility.
Like for example,
Maybe restrict.
or something, I pass the type like in the future.
So I haven't worked with that, but at least in Java, how you could do something like this, which has generics, like you could do question mark, extends, and then the parent class. So let's say it can be a student class and a teacher class, but if you have a parent like a human class, so you could say question mark extends human, and later on, whenever you are sure that if it's a student or a teacher, you can
Yeah.
get
So that reaches the point that I was showing before.
We have something like in our TX and something.
Yeah, it's like this one here. What did I do? Is that me? Yeah, I think that's the only option for.
Oh, end of slideshow. Go back.
Oh, okay, yeah, that was actually me. So to answer your question, Ali, I think that's the only option. I'm not sure if there's another scenario for this to work. Restricting the type.
So we cannot define our type later.
It would be at the instantiation of. Do you have a question too?
Do you have any examples of widgets for which you really get benefits out of, for example, I don't know, buttons that you can standardize, tables? Because once you try to get them really generic, it becomes a real pain to use it.
Tables is a good one, yeah. For example, tables is a good one. I didn't use it too much for UI so much than logic. But yes, you could definitely use it when you're using tables. Specifically, I know data tables, for example, is a good example of that.
We've been trying to standardize tables ultra generally for a while, and it's hard.
I have an example later. We can look at it if you want.
An example for JSON.
For JSON, I'll talk about it after. Roger. Okay. Oh, sorry. Yeah.
I don't know if this example, this example, but I have used it during early providers when providers came.
Yeah.
So basically, we have used a base class, it's a generic class for all the responses for the API request. So it has
For which request?
API request.
API request.
So that we have a D as a data type for like a data that we get from the API.
Right.
And error messages and the status codes are.
Yeah, like a API response.
Yeah, it can be used in that way. And
for sure.
We also created a service, a base service in provider, which mostly handles all our loading state, initial state, and error state. So it
Nice.
we use like this data type in that service as well, because it will be a base provider class for other providers. So you don't have to create it dynamic or anything. So it can handle, like, you can extend other providers by the base provider.
Shared functionality, yeah.
So,
Any UI examples?
UI.
All right, thank you. Let's look at a non-UI example or another one. Just gotta do something here, change my. I'm trying to mirror my screen. Why is it telling me this? Yeah, mirror extend too.
Oh, you want a mirror or?
Yeah.
Yeah.
Ah, okay, this one?
Yeah.
Gotcha.
First,
Is it frozen?
first go out of the slideshow.
I can't.
Yeah, it's frozen.
What just happened?
Well, maybe plug out. Just to make sure. Then, does it work?
Yeah.
Then plug it. I think so.
Okay. Oh, I know. It's because of this. Okay, I got it. It's because it's using a full screen mode. I think I know what's going on. Oh, this way. Okay, there it is. I think we're back in this. Why I can't see my. I'm gonna close this altogether. There's no other desktops, right? This one. This is good. How am I doing on time? I don't know why it's not. I'm gonna restart my machine, maybe.
Weird. Can you go to display again?
Oh, what is? Display. Can I remove this?
Yeah, why there's the. Oh,
Okay, I think I got it. Okay,
so mirror.
this one.
Yeah, mirror. Yes.
Okay.
Cool.
Okay, sorry about that. All right, so we're back. So what we're going to do is an example where generics are very useful here. It's implementing the repository pattern. So to start off, we'll have this application, which is just a demo application that represents a small forum, let's call it, where you can write and create posts, and you can see the list of posts. So we'll say FlutterMTL is great. We'll save. So we have this post here in the list, right? So let's create another one. 1, 2, 3, 4, 5, 6. Great. So this works. We have 2 posts. We have all the functionality. We have save. We have delete. The issue here is that only so we can upvote, for example. We'll upvote this one more because FlutterMTL is great. When we reset the app or restart the app, since it's in memory, we don't have this function. We don't have any of these posts saved, right, in memory. So what we want to do is we want to be able to save the data, to persist the data. And for this example, we're going to persist it in Firestore. So what I have done is I've created a repository which allows you to implement any type of persistence, whether local or remote, via remote and local handlers. Okay, so the interface looks like this. So the implementation has to implement create, update, delete, the CRUD operation, as well as the stream. So let's use that to see how we could implement Firestore persistence in our app that doesn't have it right now. Can you guys hear me all right? Okay, so we'll implement Firestore. So what we have to do, if you've implemented Firestore before, you know we have to initialize the app. And actually, I need to... Oh, there's... So we need to run Flutterfire to configure, to get the configuration options. So I've put in that's the parameter, the name of my project. So now we have the configuration for Firebase, which is this file here. So we'll take this default Firebase option and we'll pass it to our app. We'll make sure that we have the import and whatever platform. So this now is connected to Firebase. Fantastic, but we can't write and read yet. So typically you'll have to implement all the methods yourself. We've done this once using the repository, so we don't have to do it again. So what we'll do here, I'll create a global variable. I don't recommend you do this, but for this example, we'll just do this. So we'll create this repository interface class, and imported repository, and we'll assign it here when the app starts. So this is the interface. So we'll say create an instance of the repository, and then we'll register our models. We only have one model in this app, which is a post model. So here's where we use generics. Is the code big enough?
Yeah.
Okay. So here's why we use generics. So we'll pass the type here, the type parameter, as what we're trying to register. Then we'll have to provide the options, either local or remote handler. We're just going to take care of, we're just going to handle, we're just going to deal with remote handlers for today. So we'll say we have a Firestore remote data handler. And this is what you have to implement. There's a package that I created for that, but you can have any handler, any handler that you want. So this is already written. It's the Firebase remote handler, remote data handler. We'll give the collection name, and we'll give, we'll instruct the handler how it can serialize. So to JSON will be post to JSON, and it's kind of weird to type like this. So to JSON will be, I need completion here. Data will be data to JSON, and oh, okay. So yeah, here's the thing, right? I was wondering why I'm not getting. So we'll need to say what type of serializer it is, right? It's a serializer of post. Okay, so serializer of post, and we'll say to JSON is a function that takes a post and that returns post.toJSON. From JSON is a function that, that takes a JSON and that returns a post object from this JSON object, like this. All right, so this is what you need to do to implement your CRUD operations on the post object, right? Saves you a lot of time, right? So the post service now is the last thing that we'll have to edit. Currently, the logic of adding, of reading, deleting, and adding post is done in this service class, which is called a post service. And so Again, I'll show you just high level what it looks like. So we have add, update, delete, and stream posts. Right, so what we're going to do is we're just going to tear it all out, and we're going to just put our repository methods in here. So we don't need this update anymore. We're not going to use this dispose anymore. And we'll just, so we don't need this stream, this local list. We don't need it. So we'll just need these 4 methods: add, update, delete, and stream. You have a question?
Why do you use different providers instead of editing directly in the repository?
Why do I use which?
Why do you edit directly, in terms of clean architecture? The secondary layer that implements Firebase is a provider. So you could implement 2 providers and 1 repository that references.
There is no provider. Yeah, you mean provider as in the
No, in terms of clean architecture, the layer that you're implementing here is called provider.
Okay.
Instead, but you're implementing the provider in the repository layer right now, as you're doing.
This is not a repository. This is, okay, you're talking about architecture types. I didn't worry too much about architecture. This was just like a quick demo. Like I see what you're saying, but I didn't spend a lot of time architecturing. This is a quick sample just for demo purposes. So, okay, so I just want to show, so this is where the add happens. When our app clicks add, we're going to call these methods. So what we'll need to do is call our repository, say that we want to create a post, and we'll give what records that we want to create. Well, this post that we're passing as the argument to the method. Okay, so that's implementing your create in Firebase. Basically, you're done. So we'll do updates. Update is a bit more complex, obviously, because you have an object that you want to modify. So we'll say repository dot. We'll say update. We want to update. We'll give it the type of post. What fields do we want to update? Again, for the example, we're just going to pass the whole object. Updated post.toJSON. And then finally, we're going to specify how to which objects are like how to find this record in the database that should receive this update. So what I did is I implement something that's called a string filter, and basically we'll just have to say we want to update the type field, the field ID with value of our ID. This is your update in Firebase. So we'll find the record that has this ID in Firebase, in Firestore, and it will replace the fields that you passed here in Firestore. Okay, so then the rest is the same. So same for delete. We're going to say repository.delete. I typically have GitHub Copilot, which makes this a little bit faster. It's not working right now, so we're going to write it by hand. I don't know why it's not working. Anyways. So repository.delete. Use what? Repository.delete, we're going to give it the filter so that it knows what we want to delete. So the post that has this ID. And then the stream, here's a very complex, well, a lot of code. We're just going to delete all that. And we're going to say repository.stream, the type of post. And we're going to give it, again, the same thing. So the filters. Oops. Okay, so this should be that. No, actually, this is going to be post IDs dot map. We'll say we want the map post ID to a string filter. And we'll say this. And how much time do I have left, Jen?
That's much.
Okay, I'll be less than that, yeah. If I can just...
At the end.
Okay, demo will always, the rule is that...
At the end, dot to list.
Oh, sorry, at the end to list, okay. Oh, thank you so much. Okay, and then you just want to return that. Thank you. Yes, okay, awesome. All right, so these changes that we brought, so we use the repository to implement the generic methods on the type that we want. And essentially, yeah, at this point, we're good to go. The data will persist. So let's try it out. It seems like it might already have persisted. Let's check out. Yeah, it's already persisted. Okay, so we can see here, if we add a record in our database now, it will stay through like, is awesome. I can't type. Yeah, so it just added a record here. We've connected it to Firebase via just a few lines of code. So you can see that you can save yourself a lot of implementing and re-implementing logic every time. And you can do that. So now if we were to do this for another type, let's say we had a comment type, then similar steps, right? We just have to implement the repository method for each of these. That's pretty cool. So we just have to implement these repository methods. Pretty cool, right? So let's, any questions so far?
Can we also manage the cache memory of Flow without the Firebase?
Yeah, you could use to share. You could use your local. You could use local storage for sure. So that's you're going to change that in how you implement the repositories. The repository is just an interface. So that's my implementation, right? I'm just showing you one possible implementation of this. And essentially, when you implement the repository, you will just have to say, I want to do caching first, or I want to do caching and remote storage. You can change the order. You can do local first, whatever you like. So I'll show you the logic. Maybe that'll answer your question. Any other questions about this? So, yeah, I didn't implement actually local caching yet. Actually, so you'll see that essentially we have this remote handler here that is passed. That's the implementation that takes care of that. So the remote handler here we've implemented is Firestore. We'll call create on this remote handler. So in your case, you could say, I don't know, local handler. You get your instance of your local handler, and then you can say create here. You don't have to do remote handler at all. So you decide what you would do based on your business need, right? There's no right or wrong really. Or you could be a parameter that you could say cache first, caching strategy, for example, and give more flexibility to your repository. So
Usually it's a bit more complex than that for caching. You need to define your observers, you need to define your caching strategy, your eviction strategy. It's not as simple as just if you want a real cache application.
yeah, fair. Good points. Good point.
Yeah, but
There's
he wants to be able to split between Firebase and something else. And so Firebase implements all of those.
Yeah.
But you would have to implement it like you did if you want to really support more than Firebase, you have to implement it yourself.
Yeah, I mean, if you want to implement all the caching strategies, then come back. But if you just want to do like memory caching, or I don't know, just want database caching.
No, the idea, I agree with you, but the idea is that you have a way to centralize your logic to do that, right? So this just provides the interface. After that, what you decide to do, your business logic, your caching strategy, this will be up to you. But the application doesn't need to know any of that. It will just say, I want to create a X, right? And then that logic is all handled here, for example. So this is the interface. It's not a lot of code, so you'll see just you're calling the handler if it's available. There is a method to get the handlers. The handlers are just a maps. They're just maps. So there's a map. We'll just go to it. There's a map of local handlers. There's a map of remote handlers. So when you register a handler, essentially what you're doing is that you're adding the type as the key and you're adding the actual handler as the value. So you can retrieve it by type. That's for the interface. The implementation of the remote and data handler is done. So I'm not sure if there's much more to say about this. Hold on, let me just. We looked at this. What does this do? And please feel free if you have any questions to ask them.
I was thinking about how to do the UI generic. First, I'd like to thank you for your presentation.
Thank you.
About that.
Yeah.
I think if you have a graph, let's say two screens.
Yeah.
In one we have a graph, in the other we have a graph. But the difference between both of them is that the fields are different for each. So, or a graph is a table. Fields are different, so you want to filter by field. And so one that has a string, so basically you don't know what's going to be the data type that you will receive. So you just say, oh, I'll put the generic there. And then when it gets to the point that I have to decide if it's a text input or drop down, I'll just say a type of.
For example, yeah, that's a good example. Yeah.
Thank you.
Yeah, so if you have a user input field and the input field takes a string, right? It's a long text, for example, that would be a text field. And if it's a true or false, then it would be like a checkbox or something like that. Yeah, it's gonna be. Okay, so yeah, just to summarize on this, so we have a serializer method that defines how you can do to JSON and from JSON. We have filters. The filters allow you to, they map to queries, to query, what's the word? They map to query filters, let's say. And so there's string, double, integer, Boolean filters. And finally, there is the Firestore API, which this is the actual implementation of the remote data handler. And this, so the Firestore API package is dependent on the repository. It will implement this interface, which maps to where the actual logic is happening is inside of the Firestore API methods here. So this is what you would normally implement for, let's say, each of your, whichever architecture you decide to use, let's say each of your view models or however you want to do this. So this is centralized here in this package. So any app now can come and get this Firestore handler, this, share preference handler, this, Hive handler, and then it could just plug it in like we did, and based on the logic that you have in your repository, it will do this local storage, remote storage, etc. So that's what I wanted to present. That's it for me today. Thank you so much for listening.